Hey everybody, this is your calculus video on the fundamental theorem of calculus. So your objective is to be able to solve problems involving evaluating integrals, derivatives of integrals, area, and initial value theorem. So there is a fundamental theorem of calculus, just like there's a fundamental theorem of algebra. But this is the central theorem of your integral calculus. It connects integration and differentiation and allows us to compute integrals by using an antiderivative of the integrand rather than taking limits of sums. Leibniz and Newton exploited this relationship and started the mathematical developments that fueled the scientific revolution for the next 200 years. Along the way, we present an integral version of the mean value theorem, which is another important theorem and is used to prove it. The fundamental theorem is that if f is continuous and you take the derivative of the integral, you end up with the same function. So let's look at an example. So if f is x squared, then your derivative would be 2x. And if you take the integral of 2x dx, then you get x squared. Now, if there's no numbers there, then you're going to technically say plus c. And c could be any constant, like any number. The relationship between integration and differentiation is that they are inverses. If you first integrate the function and then differentiate, you get the function back again. So let's say f is x squared. So the integral of x squared dx would be, I'm going to call it function g, which is 1/3 x cubed plus c. So if g is 1/3 x cubed plus c, then g prime would be 1/3 times 3x squared, and then the derivative of c is 0. So that's why the constant doesn't really matter. And so g prime would be x squared, which is the same as f. So you are back where you wanted. So this ends up the same. To find the area between them and the x-axis, subdivide it at the zeros, which are the x-intercepts, integrate it, and add. Okay, so let's go over the problems. Now, on this first one, the first step I would do if I were working it by hand is I would distribute. So 4x times x is 4x squared, and 4x times -5 is -20x. Now, before we even evaluate the 0 to 3, we probably ought to just do the integral itself. So we have 4. We bump this to the third power and then put 1/3 in front. And we have a 20. We bump this to x squared and do a half in front. And so that gives us 4/3 x cubed minus 10x squared. Now that we want to evaluate from 0 to 3. So that'd be 4/3 times 3 cubed minus 10 times 3 squared minus, when you put in 0 to either of these, you get 0. So that part doesn't really matter. So let's see what you get. Four thirds times 3 to the third minus 10 times 3 squared. That gives us -54. And that's what we were looking for. So the other way to do this is like on the previous lesson, when you use numerical interval. So that's on the scratch pad. And you basically type it like the integral 0 to 3 of 4x. Now on this one, you need the little time sign, x minus 5 dx. If you don't have that time sign, you're going to get an error message. Just like on something else in graphing. So if we didn't have this time sign, it says, you need it, since get invalid implied multiply error. So you have to have that little time sign there, like so, and you get negative 54. Okay, so again, showed you by hand. I guess I didn't really use this part. I did the integral by hand and got my answer, and then I just used the calculator, got the same answer. So now we're going to do one going from 1 to 3. So we do menu 4, 2. So that's menu 4, 2. And then we type in 1 to 3. 3x squared minus x to the 4th over 6 dx. And so that gives you this answer. And then you do, see, when I did that, it did a little weird thing. It put a 4 there. And so if I try to make that a fraction, it's going to be weird. Well, I guess it worked. I was going to say I would have put a 3 here instead. And it gave you the same answer. So that worked. We got 17.93 repeat, which was 269 over 15. Same answer. So again, menu 4 for calculus, 2 is numerical integral. Numerical integral. Okay. Now on this one, first off, if it has to do with trig, you need to be in radian mode for trig. And so here we're going from 0 to pi 6 of 3 secant squared. So what we do is we put a parentheses, we do secant x, and then we do squared dx. Now, when I do this, I get 1.732. And if you remember a long time ago, we'd say, well, square root of 2 is about 1.414. Square root of 3 is about 1.732. Square root of 5 is about, what, 2.236. And so on. So that's one way to do it. The other way is to actually do your work. I'm going to go ahead and stick the 3 out front because that part doesn't really matter. So when we have this, this would be like saying f is 3 secant squared. And so when you do the integral of secant squared, that's tangent. So we would say 3 tan x. And you got to evaluate that from 0 to pi 6. So that means you do 3 tan pi 6 minus 3 tan 0. Or you could have just left your 3 out and distributed. I think I'm going to show that. So remember on tan of pi 6, you might want to use your unit circle. And so pi 6 has the ordered pair square root of 3 over 2, comma, a half. And so tangent would have been 1 over square root of 3. And 0 has the ordered pair 1, 0. And so that tangent would be 0 over 1, which is 0. Remember, tangent is y over x. So then we get 3 over square root of 3. And then you're going to rationalize that. So that's, well, okay, so here you could rationalize it, or you could like think about it critically. Like 3 is the same as square root of 3 times square root of 3, and then just cross it out. So that's what I would probably think of. So just from thinking critically. Now, if you didn't like that, you could have done rationalize. So if you have 3 over square root of 3, then you multiply by square root of 3 over square root of 3. And so then you get 3 square root of 3 over 3, which then turns into square root of 3. So in either case, you get the correct answer. So just as a reminder for tangent derivatives, trig derivatives, if you're doing the derivative of sine, you get cosine. If you're doing the derivative of cosine, you get negative sine. If you do the derivative of tangent, then you get secant squared. So that means if you're doing the integral of secant squared, then you get tangent. So that's how all this is related. So the first 3 are derivatives, and this is an integral. So if you're going the other direction. Okay. On your next one, we have 1 plus cosine the double angle over 2, and you're going from pi halves to 0. So it's actually identical to what I did a long time ago. So pi halves to 0 of the same function. What I did first is I split it up into half with the denominator here, and then if you have a half and you're doing the integral, it's a half t. I mean, you would have thought a half x, but we have to use the t variable. And then for that one, it's a half with an extra half of sine. And then we make that a fourth, and then evaluate it, and then get negative pi fourths, which is about negative 7.85. And over to the side, I was like, well, what is the integral of cosine? It's sine, because the derivative of sine is cosine. And so if we have sine of 2t, and we're doing the derivative of that, you'd have cosine 2t times 2, but we put the 2 in front. And the derivative of sine is cosine, basically. So that's pretty much how you do that one. So what that means is you'd have pi halves to 0 of 1/2 plus 1/2 cosine t dt. And so this is a half t plus the half of the half of sine 2t, and evaluate that from pi halves to 0. And so that gives you 1/2 t plus 1/4 sine 2t, and you're going from pi halves to 0. Now remember, if you really wanted to, you could say a negative sign out in front and put 0 to 2 pi. That way it would make a little more sense. And so then we get negative pi halves plus 1/4 sine 2 times pi halves, and then minus 0, and then minus sine of 0. So first off, the sine of 0 really is 0, because the sine is the y value. So that's really going away. And if you're saying negative pi halves plus 1/4, okay, sine of pi is 0. Oh, I see right here, I forgot the half. I just put pi halves. I need a half there. So that turns into my pi fourths plus sine of pi, which is really 0. So that gives me my negative pi fourths. Now, if you just use the calculator on this one, you would have had the integral pi halves to 0, 1 plus cosine 2x, wrap that in parentheses and divide by 2, and then put dx. So that gives you negative 0.785. And it wouldn't have matched one of the square roots. You'd have to say, you know, try pi over 6, pi over 5, pi over 4. Actually skip 5. Do 4, do 3, and do 2. So pi 6 is 0.52. Pi force is 0.785, which is what we want. Pi thirds is 1.047, and pi halves is 1.571. So those may be handy for you, and then you just convert it with a negative sign. So that's how you do that. This one, we're going from 0 to pi 8 of sine 2x. So on that one, remember that pi fours is like 45 degrees. So pi 8 would be half of 45 degrees, which is 22.5 degrees. If you just want to visualize it, so to speak, now if we're trying to integrate sine of 2x, you're going to think to yourself the derivative of what is sine, and it's the derivative of cosine is negative sine. So that means you're doing this of negative 1/2 cosine 2x, then you get your negative 1/2 times 2 of negative sine 2x. And so then all that, the 2's cancel, the negatives cancel, so you get sine of 2x. So that shows you like how to think through it. So basically, when you see something like this, this is going to give you a weird decimal. So this is going to be probably the hardest one. You're going the integral 0 to pi 8 of sine 2x dx. That gives you this 0.146, and there's no way I remember like that one. That's not a common one at all. So what we do is we evaluate this, and you basically got to do your work, think through backwards and everything. So we're going to have to go from 0 to pi 8 of negative 1/2 cosine 2x. And so that means you're going to have negative 1/2 cosine 2 times pi 8 minus negative 1/2 cosine 2 times 0. So 2 times pi 8 is pi fours. So you're having negative 1/2 cosine pi fours. And on this one, you're doing minus a negative, so that's plus 1/2, and cosine of 0. So cosine of 0 is 1, because remember the cosine is the x value. And cosine of pi 4s would be square root of 2 over 2. So this gives you negative square root of 2 fours plus a half. And so you want to get a 4 common denominator. So you need a 2 here. And then factor out your 2. Factor out a positive 2, not a negative. So I get negative square root of 2 plus 1 over 2 times 2. That cancels. So you get negative square root of 2 plus 1 over 2. Or, whoops. Okay, so right here, negative a half times square root of 2, that's really just negative square root of 2 over 4, not 2 squared. And so that threw me off a little bit. So this part wasn't right. So that's the same as that if you just put 2 minus square root of 2 like first. So that's how you get that one done. Okay, that's probably a good stopping point for this particular video. Hope that helps.